Example 3, find the optimum strategies for both players and the expected value of the game if the payoff matrix is -1, 2, 1, and 0. Okay, so last lesson, remember, we found a saddle point. Okay, we found a saddle point, but this one, I bet there's no saddle point. Let's look. What's the worst that could happen? The lowest number in the row, and then the highest number in the column. See how there's no saddle point? If there's no saddle point, you got to mix it up. That was the first thing that we said in this lesson. Okay, so the optimum strategy is for the row player to do row 1 sometimes and row 2 sometimes. Same thing for column player, column 1 sometimes, column 2. So we're going to have to figure that out. Okay, so go back, and look at what I said was the main idea slide, this thing right here. If we want to find the optimum strategies, we have to do this. Okay, and then once we know that, we can find the value by just multiplying all 3 of them. You're not going to be able to use a matrix calculator for this because there are going to be variables. But if I want to do the row player, okay, so let's look at the row player. Need to write kind of small because you're going to fill up the space. We're going to take this times that payoff matrix. Okay? And so you really have to know how to multiply matrices. If you don't know how to multiply matrices, then you can't do this problem. All right? Row times column. So we're going to take a row times a column. And, I think it helps if you understand that you've got a 1 by 2 times a 2 by 2 is going to equal a 1 by 2, right? So keep that in mind. We're going to end up with a 1 by 2 here. So when I multiply my row times my column, I'm going to have p times -1 is negative p plus. Now I'll have 1 minus p times 1. 1 minus p times 1. So if you can do that in your head, be my guest, but I'm just going to write it like this, okay? That's my first row times my first column. So that's my first row, first column entry of this matrix. Now I have to do row times second column. And so I have p times 2 is 2p. And then 1 minus p times 0, or 0 times 1 minus p. Close it. That's your matrix. Okay? Now remember what you have. You have an expression on the left and you have an expression on the right. In order to find this optimum strategy, we set those two expressions equal to each other. Okay? So let's clean this up a bit. I've got negative p plus 1 minus p is going to equal 2p, and then that 0 is going to 0 out. Okay? So just clean up each of those expressions and set them equal to each other. Write small, use your space. Okay? So solving this, I've got negative 2p plus 1 equals 2p. Okay? So just do what you'd always do to solve the equation. I'm going to add this 2p over. I get 1 equals 4p. And so p must equal 1/4. Right? P equals 1/4. So my row player's strategy, I'm going to write it over here, is 1/4. And then 1 minus 1/4 is 3/4. Remember, it's p and then 1 minus p. You should be able to do that in your head most of the times, okay? 1/4 and 3/4. Remember, this is a 2 by 2, and so there's only 2 strategies. Row 1, row 2. Now, we want to do the column player. So we've got to do basically the same thing for the column player. A very common mistake that people will make is they try to do the same thing for the column player. Remember, it's not exactly the same thing. You've got to write it backwards, right? You've got to write it in this form. If you're doing a column player, it has to be in this form. Otherwise, it's not going to work. or you're just going to get the exact same thing as the row player. So what do? We take the payoff matrix times the column player's optimum strategy. Okay. So again, we're just multiplying two matrices. So make sure you understand when we multiply two matrices, we always go row times column. Also understand your sizing. I think that really helps. We have a 2 by 2 times a 2 by 1. When you multiply those, you're going to get a 2 by 1. So make sure you do that. Okay, your answer is going to be a 2 by 1. So when you multiply this row times this column, I call it zipping up the numbers. So the first one times the first one is going to be negative p. And then the second one times the second one is going to be 2 times 1 minus p. So plus 2 times 1 minus p. That's the first row times the first column. So that's the first row, first column entry. Do you know what to do next? Second row times this column. So zip up the numbers. The first number times the first number, this 1 times this p, you're going to get p plus, then you have a 0 times the second one, 0 times 1 minus p. Okay? So you've got two different expressions. In order to solve this, you're going to set those two expressions equal to each other. So the top one says negative p plus, distribute the 2 minus 2p. Okay, that's the top one, negative p plus 2 minus 2p. And on the bottom, that's going to zero out, so it just equals p. Okay, we set those two expressions equal to each other, and that's what we get. Then clean up and solve. Negative 3p plus 2 equals p. Add the 3p over, that says 2 equals 4p. And then when you divide, you get 2/4 or 1/2. Okay, 2/4 or 1/2. And so that means that the column player's strategy is 1/2 and 1/2. Make sure you write it as a column. P is 1/2, so 1 minus p would also be 1/2. You should be able to do that in your head because those two numbers always have to add up to 1. Okay? So now, the column player's optimum strategy is to play each choice half the time, right? The row player's optimum strategy was to play row 1 1/4 of the time and row 2 3/4 of the time. We have their optimum strategies. How do we find the value of the game? We multiply. So for the value of the game, we're going to multiply 1/4 3/4 times the payoff, negative 1, 2, 1 and 0, times the column, 1/2, 1/2, like that. All right, and the dimensions of the matrices have to be right. If you mess up the dimensions of the matrices, or any one of the matrices, you're going to get an error. So if you get a calculator error or something, it's because you messed up the dimensions. Okay, so let's go back to Desmos and let's do it this way. Okay, so I'm just going to clear this out, clear all. New matrix. A was a one row, two columns. So I'm going to say 1/4 3/4. Enter. New matrix. B is a 2 by 2. I already got it. So negative 1, 2, 1, 0. New matrix C 2 rows, 1 column, and C was, what was it? Half, half, 1 half, and 1 half. Okay. So enter. Now all I have to do is multiply A times B times C, and there's my answer. There's my value when I multiply those three is 0.5. 0.5, that's the value of the game. Okay. All right, so what are my answers? Well, here's one. All right, that's the row player strategy. And here's the column player strategy. And here's the value of the game. That question right there tells you how to do everything in this lesson.